I'm Luciana di Gennaro from the University Luigi Vanvitelli, and I'm going to present the paper A Sustainable Material for Sustainable Architecture, Wood in Parasite Architecture. The pandemic COVID-19 has distorted the way of living and enjoying the space. Unfortunately, cities are often saturated and many of the public buildings fail to meet the new needs. The need to expand the spaces is a problem and an opportunity. From the technological point of view, the new buildings should be a low-impact buildings, enhancing the energy impact. It will have to respect all urbanistical and structural regulations, taking care about safety index moreover. To answer to the growing need of usable spaces, we need to expand enterprised areas. To goal this target by reducing land consumption and preserving green space, the only way is to build on the built. So the principal type of interventions are rooftop architecture, where new volumes are elevations that use roofs; parasitical architecture, where new volumes grafted onto buildings and are evidently distinct from the host structure; and exoskeleton systems, finally, that are independent volumetric expansions superimposed on the facades. From a typological point of view, we consider four layouts, three of which involve the building envelope. In the first type, the parasite volume is put on the building to create new levels. In the second type, the new volume is clearly distinct from the host structure. In this case, we could have independent foundations. The third typology concerns a new volume that extends beyond the building envelope. And in the last type, the court area is used to enlarge usable surfaces. In this slide, we can see two examples of parasitical architecture that regard the enlargement of a school in Aversa and the expansion of a densely populated residential building in Santa Maria Capua Vetere. The volumetric additions can produce virtuous effects such energy efficiency, creation of new living spaces, social services and common areas without further land consumption. These benefits should be verified in function of some important aspects like in-depth studies of the interface between the new volumes and the existing ones, the assessment of the actual technical and functional improvement of the building, structural verification related to new loads applied to the load-bearing structures and on the foundation systems, the analysis of the weight of the new volumes and the balances of the urban context from the architectural, environmental, and social point of view. New volumes can get dependence or independence relationship with the host structure. In each case, the structural aspects involved are different. The superelevation addition can be realized by the first and second typology explained in the previous slide. In the first case, we have a total dependence from the host structure. That determines the need to a global verification even if the static scheme could be unchanged, except for the dimensions of the load-bearing elements. In the second case, we can have either dependence or independence relationship. In both cases, like for the first typology, there is the need of a global verification, also by reason of static scheme probable variation. In this slide, we can see an example of a superelevation with an independent relationship with the host structure. The case of Villa Fiorita Clinic concerns a volume addition with new foundations that bear a new deck superimposed on the roof without interaction with it. The new structures present an earthquake-resistant scheme with concentric braces with hectic dissipative diagonals. This is a typical case where the addition actively collaborates to the dissipation of the seismic force, improving the original building features. The type that concerns lateral addition has to be deeply analyzed because to create a profound dependence from the host structure. So, many structural issues have to be checked. The addition represents an eccentric mass that modifies the static schemes and the seismic behavior of the whole structural system. Also, the effects of the torsion have to be verified. Load increase has to be checked. Finally, the lateral addition superimposed on the facades represents an important appearance modification. The formal aspects of the original buildings are distorted, giving birth to a new building. In the facades belong to the courtyard, the formal modification is substantially hidden. To the principal facade's appearance is unchanged. Sometimes the new volumes actively collaborate to the improvement of structural performances. In this slide, we can see as the full typological addition in the courtyard of C and U-shaped buildings can limit torsional effect due to the horizontal seismic forces. Also in the adaptive exoskeleton structures, we can entrust to the new structures the task of earthquake-resistant elements. Parasitical architecture lets the realization of volumetric addition without consumption of resource. Also, in the almost totally off-site technologies is the most suitable for its realization. The goal is the creation of high-performance buildings that are smart, sustainable, and capable to adapt to events and changes to which the urbanized areas and will be subject. From this point of view, the use of the wood and the products derived from it can represent a valid solution. The wooden parasitical architecture fully frames within the perspective of resilient thinking. Modern research and technological innovations have allowed to overcome the problems related to the anisotropy of the wood in its original configuration. A new generation of wooden-derived products and technologies have been made that fully compete with the most commonly used materials for construction. In order to create the smartest sustainable buildings, CLT, glulam, and press lamp technology seem fitting to this purpose. The press lamp system was created in response to the growing demand of seismic resilient and sustainable structures. The innovation lies in applying the concept of prestressing to prefabricated wooden elements such as glulam and CLT. This happens by creating a post-tensioning system on site through the use of sliding cables and tensioning equipment. Several studies have been conducted to analyze and recentering and dissipative characteristics of structures made with this technology, as well as the dissipative effects due to the insertion of rocking elements inside existing structures to be entrusted with the migration damage or due to the presence of metal connections for reinforcement interventions of its plan or off plan with CLT panels. The prefabrication makes the proposed solution all advantageous in terms of optimization. The faster installation and the use of elements substantially executed off-site allows to precisely establish the times and areas involved in the construction and assembly phase. That could ensure the continuation of the activities in the original building if necessary. In this paper, some possible solution has been proposed for the implementation of the spaces through the volumetric addition, called parasitic architecture. Also, the almost totally off-site technologies is the most suitable for its realization. In this sense, it seems appropriate to use laminated wood components assembled with innovative technologies. These interventions, combined with the use of wood, can be fully integrated into the perspective of resilient thinking in order to create smart and sustainable buildings. Thanks for your attention.